This is a quick and dirty little video on how to find GPS velocity data from UNAVCO station overview pages. Just use the pause button to take note of this URL because that's the page that we are going to go to right about now. This shows all of the stations in the UNAVCO library that's accessible to us online. This is sort of an inconvenient little map as it is now. I just want to make note of the fact that if you know the stations that you want data from already, you can see this information in tabular form. But if you're just searching for stations around a field area, for example, just blow up the map a little bit. Use the zoom function. This is sort of a standard kind of map presentation. And we are going to be looking for stations around a field area near Tahoe, just north of Tahoe, along the California-Nevada border. And so we're just going to keep zooming in until we have something that's useful. Now our field area is right in here, and what we're going to be using the GPS velocity data is to make an initial computation of the crustal strain, the instantaneous crustal strain in this area. And to do that, we're going to need 3 stations that form a triangle. So like those 3 stations, or perhaps these 3 stations, or these 3. There are many permutations. All we're going to worry about in this video is how to get the data from one of the stations, and the station that I've picked is P150, which sits on top of Martis Peak. So when you click on the little icon, map icon for P150, you get this initial little dialog box that has a little bit of information. And I'm going to click on this blue label, which is a clickable link that gets me to an overview page for station P150. So a lot of information on this page. For one thing, it's got approximate geographic coordinates here in latitude, longitude, and elevation in meters. But one of the things that is more useful than that to me is if I go up here to where it says time series data, I've got velocity data expressed in 2 different reference frames. NAM 14 is a North American datum from 2014. It's in a CSV text file. There is also an IGS 14 reference frame data set. And today we're going to use the North American data set. When I click on that, I get a typical flat file, text file, and the header information has some things that are of interest to us. In particular, the position of that station P150. The same data are presented on the overview page at a slightly lower resolution. So depending on what the resolution is that you want in this model, you might want to go with the data as expressed in this CSV file. So latitude and longitude are 2 of the bits of data that we need to extract from this page. The other data, the velocity data, we get through clicking on this little graphic. It loads several pages for us. This one is the process daily position time series from Martis Peak. It has a graph of the north-south positions, and so the slope of this line gives us the velocity in the north-south direction. It's a positive slope, so it's a positive velocity, meaning that this site is moving towards the north. Here's the east-west plot, time series plot. It has a negative slope to it, and negative means that this site is moving towards the west. And here's the height, the up-down, if you will, orientation. It has a slightly negative slope to my eye, but we don't really use the height in this crustal strain analysis, at least the way that we're going to do it. So we're going to press on to the next graphic. It's process daily position time series. It's clean. They've removed the points whose standard deviation are greater than 20. And the third click gets us to this frame where they've detrended all of these graphs, but they've given us the average velocity in millimeters per year plus the standard deviation. So here's the velocity in the north-south direction. The fact that this is a positive number means that we are looking at a northward directed motion. Here's the east-west velocity. And the fact that it's a negative number means that it's going west. And then here's the up-down velocity. These velocities are computed by a group at MIT, and they're based off of the same data that we saw in that CSV. These velocities are relative to the North American datum or North American fixed coordinate system of 2014, as you can see. To close, so we make note of those two numbers, the north-south velocity and the east-west velocity, and then we're done. We've got all of the data that we need to put this station's information into the software that we use to compute the crustal strain.